All right, so let's do another example. And this time we're going to do an example where, at least one base case works, but the induction step does not work. And so what we want to do is we want to attempt to prove that for all natural numbers n, 5 times n is even. And so let's do a base case. So we can do n is equal to 0, and we're going to get 5 times 0 is equal to 0 is even. Great. And then normally, as we did in the previous, examples of induction, we did like several base cases just to kind of wrap our heads around what's going on before we wrote down the proof. And we'll actually circle back to that. But now let's do the inductive hypothesis. So the inductive hypothesis is assume that P of K is true for some K greater than or equal to 0, i.e. assume that 5 times K is even, so is equal to 2 times L, for some integer L for some K greater than or equal to 0. Great. And then our induction step, basically all the other examples, is we're going to consider K plus 1. And then what we want is we want 5 times K plus 1 equal to, eventually, equal to 2 times some integer m. Or just 2 times some integer that we're going to use m. And what we're going to see is that this is not actually going to work. And so let's jump into it. Let's show it. So 5 times k plus 1, that's 5k plus 5. So this is 5k plus 5, just distributing. And then we want to use our inductive hypothesis. So 5 times k is equal to 2 times L. So this is equal to 2 times L plus 5. Okay. And then what I'm going to do is I'm going to do a little trick. So I'm going to write 5 in a different way. I'm going to write it as 4 plus 1. So this is 2 times L plus 5, which is 4 plus 1. So the 5 I did as 4 plus 1. And why I did that is because I want to be able to write this as, in fact, an odd number. So I'm going to show that this is actually an odd number. And how I'm going to do that is I'm going to factor out a 2 from this 2L and this 4. So this is equal to 2 times L plus 2 plus 1. And then what I just showed is that 5k plus 1 is not, in fact, even. It is rather odd. So it's 2 times some number plus 1. Great. And so the induction step does not, in fact, work. And we can see this if we actually do some more base cases. So if we try some more examples, if we do n is equal to 1, then we'll get 5 times 1 is 5, which is not even, And so hopefully this example highlights to you that when you're doing a proof by induction and you don't know whether or not the statement is true, if you're trying to prove that it's true, but your professor or whomever hasn't told you that it's in fact true, it's a really good idea to try several examples first, just to wrap your head around what's going on. Because in this one, it only took 2 examples to see that it's not even true. It's not a true statement. And then if you don't do that, if you don't do several base cases, if you only do one and it's not true, then hopefully you get stuck in your induction step. You see that it doesn't in fact work. And we can even talk about why this doesn't work. And so 5 times n is, an odd number times another number. And whenever n is even, then an odd number times an even number is going to be even. So in fact, this 5 times n is going to be even whenever n is even. But whenever 2 odd numbers are multiplied together, 2 odd numbers multiplied together is odd. And so 5 times n is in fact going to oscillate between even and odd, depending on whether or not n is even or n is odd. Great.